All right, let's kind of go through the homework here we do. Worksheet 0.06, 0.6, is that right? Or wait, am I on the wrong page? I just flipped it open. 1 through 6 on 6? All right, make an educated guess about the measure of each angle shown below, then use a protractor to measure the angle and compare it to your guess. So, from number 1, number 2, number 3, I mean, you're just guessing, so I guess number 1 is probably around 70 degrees. If you measure it, you get somewhere right around there. Is that right? 60, cool, I'm with you. And then a guess on number 2, it's more than 90 degrees, probably about 120 degrees. If you measure it, you get somewhere in that ballpark. 130, okay. Number 3 is probably 88 degrees, somewhere in there. That's my guess. Is everyone okay with drawing an angle using the protractor? So, basically it just becomes, some of them you have two different things. So it counts from 0 to 180 this way, and then this out one 0 to 180 that way. Just realize and understand the angle that you look at, if it looks like it's less than 90 degrees, then use the smaller the numbers. Okay, if you had some angle up here that's drawn like this, and you moved your protractor over it, does it make sense that this angle here is like 115 degrees, or does it make more sense that it's 65 degrees? 65. So just be cautious that you have two different measurements that do take place with the protractor on the majority of the protractors that are purchased. So keep that in mind when you're working on. So drawing the 72, drawing the 165, drawing the 90, I think they should be all pretty easy for you. Do you agree? And we just did 1 through 6. I did not require you to do the word problems, correct? Does everyone feel comfortable with those? Or is anyone like, dude, measuring, done. All right? All right, problem number 1, construct a copy of the line segment below. The copy should have one end point at A. So I'm just going to we have a line segment, we have a point out there. We want to duplicate the length of that line segment. Okay? So we're going to use our compass. Put my point on one end. And let's just pretend I can make it the same. I drew my line too long, I'm sorry. So if that's that, what I can do then is just move this over here and center it. And come on. Swing an arc. So now the distance from this to this line, no matter if I draw the line from here to here, here to here, or here to here, is going to be the same length. And so anywhere along that line, we would be able to, dude, you are fast. They were closed. Did you slip and fall?
No, I didn't.
Did you knock your tooth out?
No.
Dang it. Okay. It cracks me up how you guys all have your bags right in his path. Like, you're done. All right, you didn't miss too much. I think you should be able to catch up. Plus, it's recorded. It's in the first 4 minutes and 30 seconds. So worksheet number 0.7, construct a copy of the angle below. The vertex of the angle should be on point A. So let's see if I can do this a little bit better. So I have some angle, and then I have some point A out here. That point A is actually going to mimic this point right here. Is that okay? So I want to duplicate the angle. Doesn't matter which way it's going to open at this point. So am I worried about duplicating the length of the lines? No, I just want the angle. So I'm going to use my compass. Open it up a little bit. Put my point on one end and swing an arc. Okay? That arc intersected our angle, our two rays of our angle, two different times. We can label them if we want. Okay? Maybe I call this angle J. Maybe I call this point K, J and K. So I have ray AJ and ray AK to use. We want to reduplicate that. So it doesn't matter the direction of my angle. I'm not trying to make it, equal with it. So what I'm going to do is I'm going to take my point, put it on point A, and just swing an arc that I think is large enough. Then what? Yeah.
Don't you just draw a line from A to
Somewhere onto the arc. Yep. So making a straight line, and I should use a straight edge. I'm sorry, I'm not mimicking the appropriate behavior for you. But using your straight edge. Okay, good. I'm just drawing a line out. Okay. Is this now point J or point K? Do we know? We can call it one or the other. It doesn't matter. So I could say, hey, this is point J or K. Doesn't matter. What's next? Yeah.
Do the same thing from A to another part of the.
So if I move this up here, I'm still going to continue to get that same arc length. I can go 360 degrees with it. It gives me a circle around the point.
So draw a straight line to another part of the half circle.
Almost. What do you got?
Don't you measure from K to J?
I do. Good. So I have point J here. I could label it K. Okay, we're just trying to identify one of those points. I'm using it as a reference. So then I'm going to take my compass, put the point on either J or K, doesn't matter. Measure the distance that it is from J to K. Probably have to rotate this around. Two arcs cross. What point is that now by our diagram? K. Okay. Use your straight edge. I'm just going to cheat. I'm going to use my straight tool. And I'm going to draw there to there. Okay. This angle here is the same as this angle here. I could go and measure it with my protractor. It would still be the same. Yeah.
Do you want us to, when we do our, do you want us to label like points J and K or whatever label, or do you care?
So I want you to make it work for you. For me, it's easier. I start labeling points as soon as I start getting intersections, just so I know that, okay, so I know that I'm going to have a segment AK and a segment AJ on the other. That's why I'm labeling it. Is there a right way to label it? I'm just going arbitrary. I mean, yesterday I did smiley face and crying face and stuff like that. So just label it so you know, especially with, how you guys are. You'll start doing something, and then something called a cell phone will get your attention. You'll check it out, and then you can go back to your phone. Where did I start? What was that point? And then go. So I think it might be good practice to label it. Am I going to mark it wrong if I label that M and N and you decided to label it J and K? No. I'm making it work for me in my mind, which I'm trying to model a behavior that might work for all of you to make work in your minds as well. Construct a perpendicular bisector to both segments below. I'll just pick one of them. So we have this segment here. Okay. Do I know anything about this segment? There's two ends, certain distance. Kids in my next period class wanted to measure it right away and know if it should be in inches or feet or yards or anything. No, don't measure it. So I think being you're doing a perpendicular bisector, a good practice might be to label your two endpoints, maybe A and B, doesn't matter. So a perpendicular bisector will cut this line segment, which we've now labeled AB, into two equal parts. It will also create four 90-degree angles all the way around, showing it's perpendicular. Okay? So let's use our compass. Any thoughts what I should do? Yeah.
So starting at like A, you could swing an arc just a bit over halfway over the line.
Okay, so I could go all the way here if I wanted to, or I want it more than halfway. So I'd say about there is maybe halfway. I want a little bit more than halfway to all the way. It's your choice. So I'll choose to about there. Okay? And what I'm going to do now is I'm going to swing. Whoa. How did that come out so nicely? I want to swing a nice arc. Okay? Keeping my compass the same size, I might just rotate it around. Maybe I'll change the color. I'm going to do the exact same thing from point B. I have the red and the blue lines that are intersecting each other. Where they intersect each other creates 2 points. Perhaps we could name the points. I don't know. Let's go, maybe call that M and call that N. What should I do now? Yeah.
Draw a line between N and M.
Yep. M and N are I'm gonna use my straight edge. Mine, I'm just using my straight line. Let's change the color. Okay. So where that line now intersects, this right here becomes another point. So maybe I could call that point X. So things I could tell you about this is it's a perpendicular bisector. So line AB or line segment AB is perpendicular. I mean, there's definitely things I can say. So line segment AB, and remember we label a line segment like that. We want it as a line. We put an arrow on both ends. And we could say we're going to use the equal sign with a little tilde on top. Means it's congruent. It's just a geometry term. Does it really mean it's equal size? Yes. We know that line segment AB, I don't want that. I want to use line segment AB is perpendicular to line segment NM. That's the sign for perpendicular. Other things I know is line segment AX is congruent to line segment XB. So congruent means it's the exact same in length. So a perpendicular bisector, by doing this, you create a perpendicular line, meaning you create 4 90-degree angles, and then you also cut the line into 2 equal parts. You okay? So I didn't realize it until yesterday after you guys left and probably were frowning. I didn't show you all of the notes, and I'm sorry. I apologize. I didn't mean to not do that. Can I move off this? Do you feel comfortable doing this with the other one? Also, with yesterday's video, down in the comment section, I have a link that goes to the, it's short little constructions. It's like, so you can click on it. It doesn't have any words, but it shows you. Basically, what I'm showing you without a person up there is just like Khan Academy or something where it's just a little thing. All right, so we want to construct an angle bisector. Okay, so I'm going to make myself an angle. Does that look kind of similar to that obtuse angle, meaning it's more than 90 degrees, less than 180? Okay, and they're showing it as two different rays, so they have an arrow on each end if you wanted to show that. Doesn't really, it's not imperative that you know that. You do have two lines intersecting each other, so should we name it? What's a good letter? X, okay. So I want to cut this angle into two equal parts. I want to bisect it. Still with me? I don't know how big the angle is, but I know the construction that I can use to cut it into two equal parts. Compass time. Okay, so take your point, put it at point X, open up your compass a little bit, and swing an arc large enough that you have it intersect the two rays of the angle twice. Where they crossed twice created what? Two more points. So let's name this point, I don't know, we already have point X. What else should we name? Give me some letters. Greek, I don't care. Emojis. What? Alpha? Alpha? Alright, let's go lowercase alpha like that. Works for me. Huh? Alright, you make me go there. I know, that's kind of bad taste. I probably should get rid of that. I don't know. Alright, let's label that omega. Huh? Greek letter omega. They're just variables. We're just naming them. So lowercase alpha, omega. We're going Greek letters. Why did I change to Greek letters? Just cause. For those of you sitting there going, what happened with the regular alphabet? We had like 25 other letters to choose from about. I know. So we're just picking Greek letters now. Who cares? You can name it letters you want. Okay, for those of you who are upset about this, label this A, label this O. Sound good? All right. Any thoughts on what I should do next? I've made two more points, alpha and omega. Yeah.
You measure the distance between alpha and omega and swing it around G.
Swing it around G. Okay, let's try that and see what happens. So bring this, I'm going to measure this distance. Oh, that's a distance I don't have yet. And then let's open it up. That could work. What do you think? What would that do for us? Let's change our pencil to a blue. What's this going to do for us if I do something like that? Make a circle. Do I really need the whole circle? Probably not. So if I'm going to cut the angle in half, let's do something like that. Let's go. Oops. Measure this distance. Come on back. I like that. That should be a good distance, I think, right? And let's swing an arc. Okay. Let's keep this the exact same. Come over here. Swing another arc. Is there a place where the new red and blue now intersect? That might make sense to call another point. Seems like a point of intersection. Let's call this palm tree. You're not a very good artist. I know. So I named it palm tree. Yeah, we're getting out of the Greek letter system now too. So all I did was just measure the distance between the two green points. Kept the pointy end on one of the green points, swung an arc. Kept the compass the same length, and swung the same size arc from the other point that I had labeled. And now they intersect each other. Does it appear where that point exists, if I were to draw a line from point X to now that palm tree, does it make sense that it looks like it might be cutting that angle in half? Maybe, I don't know. I'm going to use my straight tool to draw this in. And if this works, we can do how could we verify if that's angle, those two angles are equal to each other? Yeah, let's measure it. Use the protractor. I want you to move. I want you to move. I want you to move. There we go. Let's bring that up a little tiny bit. So this angle here appears to be about 62 degrees roughly. And if I swing this around like this, then this angle here appears to be about 62 degrees as well. Does that justify that we have, bless you, does that appear that we have an angle bisector we've created? I think so. So now things that we could say is this angle here and this angle here are congruent to each other. I just put a little line tag there to show that those are congruent. If they're congruent, that means they're the same size. Are they the same angle? Theoretically, not the exact same angle, but they are the same measure of each angle, so we could say that they're congruent to each other. What do you think? You should be able to do the other one, the acute angle. Then it says, given A and B below, construct a new angle. Wait, given angle A and angle B below, construct a new angle with its vertex at C, whose measure is equal to the measure of A plus the measure of B.
Say what?
Let's try and draw that. May I move off the screen? So measure A. Measure B. Do those appear to be two angles that are less than each other? One's less than the other. Okay. So we call that A. We call that B. What they want us to do is to go angle A plus angle B will equal angle C. So what I'm going to do is I'm just going to use my straight edge. I'm going to call that C. What do you think?
So what I did was I swung an arc for A to like create 2 points, and then I used that distance to give it on C, and then that created another line on that
Okay.
to make part of it.
So that sounds like you're duplicating the angle, and then you're duplicating the other angle using the new drawn ray. Okay, I like that. Let's try that. Let's see if that works. Compass. So I'm just going to open this up a little bit, swing an arc. Did that create 2 new points? So notice I'm just going to bring this straight down here and do this. Is that all right so far? So this defined 2 points, this defined 1 point. How am I going to figure out the distance from here to another point? Should I use the compass to measure that new distance? Sure. new distance. I'm going to get my pointy end here. Close the compass a little bit. There we go. So now I can come around with it. Swing an arc. Move that out of the way. That point creates a new point, correct? So if I go from C through that point, that should generate us this point or angle A. So I'm going to use my straight edge. Goes right through it. So now I'm going to do the exact same thing, but using angle B. And angle B, I'll still use point C, but I'm not going to use the orange line. I'm going to use the red line as my base. Okay? I don't have to keep my compass measures the same. Oops, get out of there. Open up a little bit. Let's change the color. Let's swing our. That changed the size of that. I now have defined two new points on angle B. I could label them if I wanted to. But what I want is this, one of these lines to be along this line now. And if I lay it on top of it, I should be able to come up. So I'm going to use point C, that's the same as point B, keeping my compass open to the same measure I was just at. I'm going to put my pointy part on there, and I'm going to swing an arc. Okay, yes, it did happen to intersect here, but we're not worried about that. We're worried about here and then something up here. What should I do? What should I do to get that one extra point to this blue? Yes, I understand this blue did intersect this line. It did intersect this orange line. Great. Okay, but I want the angle to be here. So what's the last step that I should do? With the blue arc with B. Good.
Measure the distance between the 2 points.
Yeah, see these 2 points here? I'm going to measure that distance. So it appears to be that. Then I'm going to move my compass. I have to flip mine over a little bit. I'm just going to swing myself an arc here. I kind of do a big arc. Oh, now it's all messed up. All right, so this point right here, let's see, that should be right there. I'm going to use my straight edge. So, this angle right here, this purple, is this angle added to this angle. And of course you want to ask, why don't I just use a protractor, measure the one angle, do the same thing, measure the other, do the same thing? Because you want to use the tool of geometry as the compass, not the protractor. This is way different than you've ever thought through math, I bet you. Are we okay? Questions? Yeah? No? Yeah.
How do you get the distance in between the lines? How do you measure that? So it's the same as A and B.
So here,
Yeah.
I put the pointy end and the colored end, or the writing end, to measure this distance right here. And then what I do is I do the same thing here, and I swing the arc. Because I could find this arc length when I measure that. And then this one, this blue one, was this bigger one. And then I can measure those distances from the line to swing the arc. Did I answer your question?
Yeah.
Do you want me to try another one?
Yeah.
Okay. So this is just a random question. Let's duplicate this angle through a point. So let's pretend we had a point that we labeled on here, and then I just drew a straight line right through that point. Is that okay? So I'm going to label this also point A, because this point A and this point A are going to become the same thing. Still with me? So now I'm going to take my compass, I'm going to open it up a little bit and put my pointy end on A and swing an arc. And I'm going to swing an arc large enough that it touches both of the rays. Okay, so I'm going to open up my compass a little bit, move my compass up here, pointy end, colored end, swing my arc. All right? Do you see these 2 points here? Okay, I could label those if I wanted to, or I could leave them as is. My compass did not change size, so I'm going to take my compass, I'm going to put it here on point A, and I'm going to swing another arc. In this way, I only touched one line. So A to this point is either A to this point or A to this point, doesn't really matter. Okay, does that make sense so far? So the last part is I'm now going to measure the distance between these 2 points that are defined with my compass. So I'm going to have to change the size of my compass a little bit. Oops. So pointy end on one of them. Close it up a little bit. Okay, so that's now that distance there. I'm going to keep my compass the same. I'm going to come over here. It looks like I should flip-flop it, huh? I didn't change the size of it. I'm just flip-flopping it. So I've measured the distance. So remember, this distance here is now mimicked here. So this is a new point because 2 arcs intersect each other. I'm going to use my straight edge and just go right through. This angle right here is the exact same angle as this right here. And that's how I do it. All right? All right, so I'm not going to collect those today because, for obvious reasons. I have a new page of notes, and it's a lot of, I wouldn't put this in your notebook right away. What I do is I keep that on my desk with your compass, straight edge, and writing utensil. That way you're not trying to balance all tricky on your notebook. That's the perpendicular bisector one?
It's the bisector line.
You make the perpendicular bisector first. Stay with me. And then pick one of those angles and cut it down. Do an angle bisector. I'll do another one. I bet you there's another one. Mimic that one. Yeah, need another? Yes. I can't count still. Jeez, you think after like the second day of school. I've told you guys, there's 3 kinds of people in the world. Those who can do math and those who can't. Those who can't do math are now going, wait a minute, wait, you said there's 3 people in the world. Where are we going? Come on, go to the beginning. All right, 0.8, section 8, constructions part 2. Develop an understanding of how to construct perpendicular lines and parallel lines through specific points. Clarify skills needed on success for chapter 0 test. Because chapter 0 test is tomorrow or Thursday? on the yellow sheet.
Oh, it's on Thursday.
Oh, okay, good. You guys don't start getting scared. Yeah, I guess Thursday we have a test. All right. Like, dang it, I just didn't start crying myself to sleep yet. You should. All right, for each construction we learn, you need to watch me complete one, and then you're going to complete one with me, and then we'll complete one on your own. Good? Y'all ready for this? So if you watch me complete one, that means I'm doing mine by myself. So talk me through this one. Construction of a line perpendicular to a line through a specific point on the line. Is this asking for a perpendicular bisector? Is the word bisector up there at all? No. Am I looking for the perpendicular bisector then? No, I'm not looking to cut that line in half, but I'm looking to create a line perpendicular to it that goes through point A. Does that make sense? So on the cheap, we're looking to do this. Okay? But a little bit more complex than just me freehanding a drawing. Okay? So let's undo that. All right, so, I got my compass right here. Good. All right. Going over. I'm going to put my pointy end on point A, and I'm going to open this up a little bit. And what I'm going to do on either side, keeping the distance the same, is I'm going to swing an arc. Now, if I want, I could swing it all the way around, but I probably don't need to. And I'm going to rotate this around this way, and I'm going to swing another arc right here. All right? So now I just picked an arbitrary distance on my compass, and so the distance from A to this green line is the same distance as from A to this point. Agree? So from there, I have a point already established. So what I'm going to do is I'm going to open the compass a little bit more further. And I'm going to come back over to each of these points. I opened it a little bit further. And I'm just going to swing an arc up here. That looks big enough. Keeping my compass the same size. I'm going to move it over to here. Put my point right there. Swing a blue. Where the blue and the red intersect, we create what? A new point. So we have the red-blue point. So from there, I'm going to use my straight edge. I'm going to connect point A to the new point that's generated by the red-blue arcs. Whoa, dude. That shouldn't have happened. So, this line right here, I could have, I guess, brought it straight down. Okay, that line right there is perpendicular to the black line. The green is perpendicular to the black. It also goes right through point A. So, first step, let's write the steps down. First step, swing, arc, each side of point. And then put in here, must be same. Meaning, don't open your compass, swing an arc, close it, and then swing another arc. Keep it the same distance. And then, open compass, wider, such official terms. So if your compass was like this originally, open a little bit wider than it had been, swing two arcs above or below to create a new point. Connect dots. That's all it is. So do we make sense? Swing an arc from each side of the point. Swing an arc, swing an arc. It's the same. The compass wider than it had been. Go to the new point, swing an arc. Go to the new point over here, swing an arc. I'm no longer using point A. I'm just swinging new arcs from the green, the dark green to dark green. And then they're going to intersect. Now I could have done this. I could have swung an arc up here and down here, as well as up here and down here. And that would have actually created the perpendicular bisector to this segment here. But it's not necessary to do because we're going through a point. Yeah?
So after you swing the first arc that creates the 2 points beside A,
Yes.
then you just open it up to the wider and start from one of the points.
Mhm. And swing either above or below or both. And you do the same, and then take the compass, flip-flop it. Okay? So let's see if you guys and girls can do this. Is this the next one? That's you. Try it. Yeah.
So why can't you just like draw a line? Isn't that just do the same thing?
You just want to draw it on. But I'm making sure that it is perpendicular. So if I swing, so if I swing an arc, if I freehand a drawing, it might look real close, and if you were to measure it with a protractor, you'd probably get it off a little bit. By doing it this way, you get it exact.
Okay.
What's the big deal with doing it? It's because this is a construction tool. Yeah.
Okay, so I'm still a little confused on the what we just
Are we here? We're on this one?
not that the one before it.
This one?
Yeah.
Okay, we're doing the exact same thing, so ready? I'm going to walk through it. You tell me when to stop. Opening the compass a little bit. Swing an arc, put the point on point A. Swing an arc. And then I need to flip-flop my thing, and then swing an arc. Keeping that the same. You good with me?
Oh, the same distance.
So this distance here, A to blue and A to blue are equal.
Okay.
You good?
Yeah.
Flip-flop this again. Okay, I'm now going to open my compass a little bit further. Right?
Yeah.
Okay, it's not any of these distances, it's just wider than this distance. You're going to put your point here. I'm going to kind of rotate it up this way. And then you're going to swing an arc. You okay there?
Yeah.
Keeping your compass the exact same. You move your point to the other black blue and swing a second arc. So there's now the blue-red point. What should I do with that? What should I do with the blue-red point now? Make a point from, or a line from where to where? A to the new point. Okay, and I'm cheating. I'm using my straight edge that's given to me as this tool. But that right there creates a perpendicular line going through point A. I guess technically this line I could continue it south like this. So that's perpendicular. It doesn't have to be the perpendicular bisector, it's just perpendicular. We are out of here soon, aren't we? So, what we're going to do is we will have to continue our notes. How far did I get on this packet? Just the first page? So, all right. So we'll continue this tomorrow. I bet you, though, you could finish those problems on the homework that we had done adequately. And then I'd say give those word problems on the first one a shot. So on our worksheets, we had worksheet 7 and 8. Was that what it was?
6, 7.
6, 7. Thank you. I think 6 and 7. Worksheet 6, you have a few word problems. Give it a try. See what you can do. And then 7, there wasn't. So just try and get 6 and 7 complete, including the word problems. Just do a good try on the word problems, though. Deal? And then we'll work on the rest of this tomorrow. And it'll be kind of a review as well tomorrow.
That packet's
So we will take worksheet 6 and 7 tomorrow. I will pick it up. And then that one packet, yes.
okay.
What packet was it though? There was a packet, I know where it was.
It's due.
Is there a number on it?
0.00.
0.0 what? 0.4. Yeah, there was a packet I handed out to you guys that I'll be make due tomorrow too.